Right, so let's look at the solution to B7 here. It was saying that figure B7.1 shows a soft ion bimagnet. So this is what they have shown you here with the north and the south pole. Then A1 says draw the magnetic field lines resulting from the poles of a magnet shown in this one. So of course you need to draw them nicely. In this case the north pole is considered to be positive, so therefore the magnetic fields are coming out, and the south pole negative, so they're entering. So remember, they never cross each other. So that's the way you are supposed to draw them nicely. So you can draw them nicely. Alright, so they never cross each other and they move from north to south. So you can actually get to, if you want to indicate the direction of the arrows, how they move out. So from the north they move out, and in the south they actually are entering, and they never cross each other. So you can just draw them nicely. They shouldn't be crossing each other, not at all. That is going to be wrong. And the same number up there and down there, so make sure that you distribute them equally, otherwise it will show that one side is is less magnetic than the other. And that's why A2 says give two properties of magnetic field lines. So one, I can simply say they are invisible. So you can't see them with your naked eye. You need ion filing so that you're able to demonstrate them. Two, we can simply say they are vector quantities, meaning they are vector quantity because they have both magnitude and so they show they have got both magnitude and direction. No wonder I said they move from north. That's why arrows are coming out from the north, as you are able to see, and they're entering from the south because they are vector quantities. Then the other one that we can say is that they never cross each other. So even as you draw them, they shouldn't cross each other because they never cross each other. Otherwise, that would make your diagram to be wrong. Okay. B says state two effects the poles of a magnet have on the poles of other magnet. Now, when we talk about the poles, a pole is simply a charged region around a magnet. So when you hear the word pole, you're simply talking about a charged region around a magnet. So that is what we call as being a pole. It can either be positive. If it is positive, we treat it as north, and if it is negative, we treat it as a south seeking pole. That's why you have got north and south. This one is treated as positive and that one as a negative. Now the question there says state two effects the poles of a magnet have on the poles of other magnets. So two effects that you are able to see is one, you are able to see, in this case, if you want, you can say attraction. So you are able to see attraction. In this case, magnetic poles can attract magnetic materials even if they are not magnetized. So you'll be able to see attraction. Two, you'll be able to see repulsion. So you are able to see, for example, attraction, when you bring two unlike poles. What happens when you bring two unlike poles, north and south? Of course, there's going to be attraction in this case. But what about if you bring north and north? There will be repulsion. What about if you bring south and south? There will be repulsion that you'll be able to see. So those are two effects, attraction and repulsion. If you want, we can also put up induced magnetism. So sometimes maybe I can just bring that one, induced magnetism. Remember that magnetic materials like iron can become temporary magnetized, so they can also show induced magnetism. But of course, attraction and repulsion stand out to be the best. Thank you so much, and watch out for my next video as we look at BA.